Hi, welcome to the College Algebra Example 1 video for Unit R, Day 1 Notes. It says determine which sets of numbers to which each value belongs. So this Example 1 is writing sets of numbers using set notation. Here we have the square root of 4 minus 6. We can simplify this. The square root of 4 is 2. So we're going to go ahead and simplify this down. 2 minus 6 gives us negative 4. So I'm thinking about, okay, which sets of numbers does negative 4 belong to? Overarching, it's actually easier for this to find like the most specific one that it fits and then move from there. So if I go back to this side here, negative 4 is not a natural number. It's not a whole number. It is an integer. So because it's in the integers, that means it's also a rational and also a real. So I can write out all of those, or I can use the symbol to abbreviate. So the sets that which negative 4 belong to. So negative 4 is an integer. Integer is z. So I'm going to say z. For integers, I could also write out the word integers. It's also a rational. So q, and then also a real. So my script R. Square root of 5. Square root of 5 is a non-repeating decimal, if I get the approximation for that. So because the square root of 5 is that, then that's going to fall in the irrational category. So I could either put I or I could put H. And then it's also a real number. 0. Well, 0 is our textbook example of a whole number. So it is a whole number. Then it is also an integer. So z is a rational. So q. And then a real number as well. And then these symbols here, this is the absolute value. Absolute value is distance. If I simplify this, negative 5 minus 10 is negative 15. So I have the absolute value of negative 15. The absolute value of negative 15 is positive 15. So so 15 then falls in the same category as the counting numbers. So that's natural. So that's going to include the natural numbers, the whole numbers, the integers, the rationals, and the reals. Be careful. A lot of students will go through this entire list and then write them all down. Remember, irrational, it's either irrational or rational. It can't be both. So natural, whole, integer, rational, and then real. There's example 1. Example 2. Given A is the set of 1, 2, 3, 4, 5, and 6. B is the set 2 and 4. And C is the set 0, 1, 2, 3, 5, and 8. Determine whether the following statements are true or false. So B is a proper subset of C. So will 2 and 4 both fit? B is 2 and 4. Will 2 and 4 both exist within C? 2 does, 4 does not. So this is a false. You need to have all of it be true for it to be true. C is a proper subset of the whole numbers. So what I'm looking for is, are all the elements, that's the things inside the set, are all those contained in the whole numbers? So looking at this, 0, 1, 2, 3, 5, and 8, all of these are whole numbers. So that means it is contained within the whole numbers. So this is true. 104 is an element of the whole numbers. You don't actually need to be looking at any of these up here. This is talking about just in general. 104 is an element of the whole numbers. B is a subset of A, proper subset of A. So 2 and 4 are both contained within A, so this is true. 0 is an element of the natural numbers. That's false. Remember, 0 is an element of the whole numbers, but not an element of the natural numbers. This says 2 is not an element of the whole numbers. Now, thinking about this, is this statement true or false? Is 2 is 2 not an element of the whole numbers? Well, that's false. 2 is an element of the whole numbers. So what it's saying is incorrect. So this is false. And then the set C is an element, the set C is a proper subset of the natural numbers. So all of these numbers here must be contained within the natural numbers. 0 is not, so that is false. Example 3, approximate each irrational number. So if you think about basically using a calculator, that's really what I'm looking for on this. So I'm grabbing my calculator. As I said earlier, I used the TI 84 Plus Color Edition for this course. So what I have here, square root of 15. So that's approximately 3.8. The square root of 84, approximately 3.9. Excuse me. And then 9.2 for square root of 84. Then the cubed root of 29. The way that you do cubed root on this calculator is you go to the math menu, and you can do one of two things. You can do, for this one, number 4, option number 4 actually puts the cubed root. This x is if you have different roots, you would put that number first. So like if I want to do the 5th root of a number, I'd do 5 first. For what we need, we can just do this. And cubed root of 29, and that is approximately 3.1. And then here I have the square root of 8. And then divided by, notice I used the right arrow key to move over. And that was, I just want to have the square root of 8 underneath the radical. I don't want to have the entire thing underneath the radical. I get a different number or a value if I do that. And this is approximately 0.9. Join me in the next video where we go over example 4, maybe. Nope, actually we can do example 4 in this video. I was looking at my time. I want to make sure that I had enough time. So example 4 is also now membership of a set. This determine whether the statement is true or false. Are the natural numbers contained within the rationals? So if I go back to my chart from earlier, are the natural numbers a proper subset of the rationals? That is true. Are they whole numbers a proper subset of the integers? So they are contained within that. That is also true. H is irrational, so are the irrationals contained within the rationals? They are not. They are two separate beings, two separate entities. The last one, are the integers contained within the real numbers? Again, going back to my chart, yes. All right. Next video, we'll pick up on inequality symbols. Have a wonderful day.